define AXI protocol in this five independent channels we have, right? In that write address channel. Write address channel, what it is doing that? What is the use of write address channel? It is sending the control information, okay, from master to slave and address. It will send the address as well as control information to slave. That defines where I want to do the where I want to place my data. So that will tells you the if you place the address means that will tells you okay where I want to keep my data and then how much data I want to keep that. Control information means how much I need to place the data. So after that write operation, how much data you need to place. So that will tells you that write address channel. Okay, so write address channel we are having master to slave, how the data is transferring or control information is transferring. Here we can see these are the different signals. Handshake signals are common for every channel, valid and ready. So write address valid and then write address ready signal is there. Okay, valid and ready signal. After that, these are the control signals and data signals we have. Okay, address signal, length, burst, size, burst, and ID. Based on the ID only, we are telling that. So, is that doing out of order transaction or same order transaction? Okay. And then protect signal, catchy signal. So these are the different signals. So protection means secured access, normal access, or privileged access. It will tells you that. And then catchy signal. So what it is doing that? So is that readable, writable, and then bufferable signals? It will tells you that this catchy signals. Okay, and then valid and ready. So valid signal should be sent by the master and ready signal should be sent by the slave. Okay, so this is the master assets that valid signal should be high. Okay, it will tells you so how much address I need to send or control information, how is that address and control information is valid or not. So based on that this signal should be, we need to set that. And then ready signal, where we need to get the where we need to place the data. Okay, so your slave will send you that ready signal should be ready. I'm ready to receive the data. Okay, so then whenever valid and ready signal should be high, then only the transfer is occurs. Okay, so the transfer is happening when valid signal should be 1 and ready signal should be 1. Both the signals are happening at the same clock edge. Okay, so you are sending the valid signal, this is the one, and this is valid signal, and this is ready signal. So both the signals should be coming at same clock edge. Okay, rising of the clock edge. So if you take the A clock here, this is the clock edge. At this clock only we need to get the valid and ready signal should be high. These are the signal description. What is the purpose? Valid, so master to slave will send that. So it is 1 bit width. Valid, ready, all are 1 bit width. Okay, so the width of the signal is 1 bit. And then address is either 32 bit or 64 bit. Okay, it is also sent by the master to slave. Okay, master is sending from address bit. And then length, so length will be supporting either 8 bits. That means if it is AXI4, 8 bits. If it is AXI3, 4 bits it will support. And then burst size is 3 bit. Based on the 3 bits, if you can see, so the burst bits are there here. Okay, size of the bits is 3 bits. Okay, 0, 1, 2, 3. Okay, 0 bit means 2 power 0. 2 power 0 means 1 byte data you can transfer. And 1 means 2 power 1. So 2 power 1 means 2. 2 bytes of data you can transfer. So 1 bit you can transfer 2 bytes. And then 2 power 3 means 8. So that means 8 bytes of data you can transfer for 1 bit. Up to that 2 power 7. 2 power 7 means 128 bytes of data you can transfer. Okay, so per bit, that tells you that burst bit. Okay, so burst size is a 3 bit. And then W burst. So W burst is a 2 bit. So based on the 2 bit, it will do that which type of burst transaction I want to do that. Here 4 bytes of burst types. Okay, 00 means fixed burst it can be doing. and 01 fixed burst means the address is same entire the transaction. That means suppose you are taking 0x1010, this is your address. Okay, that address is same entire your transaction. Transaction means all bits are transferred, not per bit. Okay, so all bits are transferred based on that. How we are telling that bits are, so based on that burst length. Okay, burst length, it will tells you that AW length plus 1. Based on that burst length, we will know how many bits are transferred per byte. Okay, sorry, how many bits are transferred per transaction. For one transaction, how many bits you are transferring. And then transaction identification is tells about this ID signal. So this ID is a 4 bit, 8 bit and 16 bit width. Okay, so based on that ID we will track that is that doing out of order transaction or outstanding transactions. It will tells you that that is the transaction identification. Based on that ID we will tell you that which type of transactions you are doing that. And then protection and attribute signal, p-prot signal. So protection is a 3 bit, so bit 3, bit 0, bit 1 and bit 2. If bit 0 it is doing that, if it is 0 means it is doing the normal operation. That means master to slave, it is doing normal normal data transmission. And then privileged access means, so privileged transfer means this is the master 1 and then master 2. Okay, if you are transferring the data from the slave, okay, master 1 is communicating and then in between that master 2 also want to communicate with the slave. So if it is having the privileged access, then master 2 will be communicating with the slave, so the master 1 will be on hold. And then bit 1 is 1 or 0. If you are doing that secured access or non-secured access, this bit 1 will be tells you that. Secured access means, so in between that locked access will be doing that or not normal access you are doing that. Okay, that will tells you that secured thing. And then in based on that data you are transferring or instructions you are transferring, based on the bit 2 it will tells you that. If it is 0 means it is doing that instruction based transactions. And then catchy signal, catchy signal will tells you that is that storing the signal or is that data is holding that, and then is that read is allocating or write is allocating. Okay, so it will tells you that catchy attributes. So catchy attributes, it will sometimes stores the data and sometimes it will holds the data and sometimes it is allocating read operation and then sometimes it will allocate that write operation. And then these are the advanced signals. So AXI4 signal locked access. So in this exclusive locked access is used. Okay, I have explained that locked access is supported by the AXI3 and then exclusive locked access is supported by the AXI4. And then quality of services is provided by the AXI4 and region. That means which region you are operating. Okay, based on the region. So this region signal, so which region you are accessing the data, so that will tells you this region signal. And then user signal, so user purpose, any signals you want to do the operation, that user signal will tells you that. Okay, so this is the user defined signal. Something you want to access something, so at that time some reserved signals we need, that is the user signal. See, sampling how it is happening here. AXI clock signal, every rising edge of the clock we are transferring the data. See, valid signal should be high and then address signal should be maintained control stable and then ready signal should be high, then only the transfer is happening. Okay, at this clock edge is happening and this clock edge also data is happening. Data sampling is happening. Okay, transfer is complete when rising edge of the clock and also valid signal should be 1 and ready signal should be 1. Based on that only we will do the transactions. Understood? So this is the basic thing, basic signals or basic information about the right address channel. These signals we need to maintain. Yeah.
Outstanding transaction.
Outstanding transaction means, so you are sending, see, beat 0, beat 1, 2, 3 and so on. So, okay, beat 0, suppose your bus size is 4, okay, so that means 2 power 4. 2 power 4 means 16 bytes of data you are transferring. Okay, 1 byte, so in beat 16 bytes of data you are transferring. In beat 1 also, if suppose beat 1 also, you are transferring 16 bytes of data. Okay, so byte 1 is transferring, the remaining bytes will be waiting in a queue. Okay, so byte 1 is transferred, byte 2 is transferred, byte 3 is transferred. All these bytes of data is waiting in a queue. Okay, that is outstanding transactions. Out of order means, suppose I'm having different data. So ID1, ID2, ID3, different IDs of data we are having. In that, ID3 is responded first, ID1 responded next, and ID2 is responded last. Then any order we will get. Okay, that is out of order transaction. That means it depends upon the slave, we are getting out of order transaction. That means slave respond in any order based on your transactions. Okay, so these are the key points, you can study this. Okay, uh, what is that? AAW channel address and control information only sending that, so it is requesting that, and do not transfer any data here. After in W data channel only we are transferring the data. Here we are requesting that, so which data, which memory location I want to access that. So then enabling the pipeline, for that throughput is high. Okay, if you are enabling the pipeline means, so and also supports that multiple outstanding transactions. So if your ID is same means same order will be getting. All IDs are same means each and every whatever the order you have given, same order we will receive the transactions. So this is the independent channel. So independent of write address channel. That means after placing the address and then control information, based on that you need to keep the data in the write data channel. So this is the write data channel. In this write data channel carries your actual data from master to slave. Okay, so that actual data you are placing, after that phase address phase is completed, then it is entering into the data phase. Okay, in the data phase, what we are placing, so what type of data you are placing, it will tells you that. Okay, so this data delivering, this is what we are doing, data delivering after placing the address. Okay, suppose you are accessing one master, this is my master. Okay, this is your slave. In this slave, I want to access this memory location 1000. Okay, so this location I want to access that. Then master we need to set the address. Okay, through AW channel. In this AW channel, it is a 32-bit address location. Then I want to place that 32-bit hexadecimal, some A, all A's, 8 A's I have placed there, or 8 zeros I have to place there, or 8 ones I have to place there. Okay, after the data signal, what are the signals we have? W valid and ready signals are common. In write data channel also we are having valid and ready. So valid signal should be sent by the master and ready signal should be sent by the slave. Okay, both the valid and ready signal should be happening at the rising edge of the clock, then only your data will be transferred. Okay, see, this is also same thing. See, this is the rising edge of the clock, valid signal will be high and ready signal should be high. Then before that this data is not transferred, because valid signal and ready signal is not high here. This data 2 is transferred, data 3 is transferred, and then data is transferred. This W last, when we are placing that W last means after transferring all the data, okay, n number of data you are having, after that sending the last data, then we are placing the W last signal. Okay, if you send last bit of data, then your W last signal should be 1 here. Okay, and also we have OK responses. Okay, so in that means response channel. Okay, in the response channel, all the data are transferred, then only the OK response will be high. Okay, we will see the next slide. Okay, so this is the write data channel. Write data channel, see, I am placing 32-bit data, so that is deadbeef I am placing the data. So based on that 32 bit, 64, 120 bit, 128 bit, based on the data with dependencies, we are placing some data. And write strobe signal, I told you, write strobe signal will tells you which byte lanes I'm having valid data. Okay, you are sending your length is 3 bit. That means 4 bits of data you are transferring. Okay, 4 bits of data is transferring. In that data 1, data 2, data 3, data 4. 4 data you are transferring. Based on that, so valid and ready signal should be always high. Based on that, I am transferring my data. This all ones means all bytes of data or all bits of data are valid. Sometimes I'm placing that 1010. See here, example of right slope signal. What we are seeing here, all ones means all bytes of data are valid. Okay, and then 0011. That means so this is beat 0, 0, 1, 2, 3. Okay, so here 1 1 I got that. That means beat 0 and beat 1 are valid. Okay, and then 1100, that means 2 and 3 are valid, and 1010, that means 1 and 3 are valid. Okay, so 0101. Okay, so 0 and 1 are sorry, 0 and 2 are valid. Okay, so based on that one signal, what is the what type of sorry, what byte of data is valid, it will indicate that right slope signal. In the last signal, I told you that after transferring the all bytes of data, then only the last signal should be accepted. Okay. ID, you know that. Okay. AXI WID. WID is supporting by the AXI 3, and then AXI 4 is not supporting. Okay. AXI 4, this WID signal is not available. Okay, it is removed. And then user signal is user defined signal. This is the advanced signals we are placing. W user. Okay, based on the user, if you want to write anything data, so user will write here. Okay. Any doubt in this AXI4? So ID will tells you that we will track the transactions. Which type of transactions I am doing that? Out of order transaction or same order transactions I am doing that? That will track here. Okay. So what are the common mistakes we are doing here? So W last is mismatching with AW length. Suppose AW length is 3, then burst length is 4. 4 bytes of data is transferred, then only we need to place the W last signal should be 1. And then right stroke signal is unaligned and partial rights, so that should be incorrect. So we need to place the right stroke signal should be aligned. Okay, so aligned, and then all the data should be valid. That will take care of that. And changing W data or aligned means, see, whatever the bytes of that, suppose 32 bit we are sending. Okay, 32 bits means 4 bytes you are transferring. Whatever the start address you are having, that address is divisible by with this 4 bytes of data. Okay, so then it is aligned. It is divisible, and then reminder you got the 0 means aligned. I will explain them in further slides. And also, if it is not divisible by 4 or 8 or 16 based on your number of bits transferring, then it is getting that unaligned data transfer. Okay. So these are the key common mistakes you can see there. And right response channel. Response means after sending the address phase and then data phase, you are placing the you need to place. Okay, slave is received data perfectly, so control information is received or address information received. Okay, based on that, the slave need to respond to master. Okay, then only I will know. Okay, so my data is placed there successfully into the slave. Okay, so then right transaction is happening properly. So based on that slave response only, I will know that. Okay, here also we are having valid and ready signals. Okay, master is sending the valid signal, and then the slave is sending that ready signal. Okay, master is accepting the valid signal, slave is accepting that ready signal. Both the signals are happening at the same transaction, same clock edge, then only transaction will be happening. This point is repeating in every channel. Okay, and these are the response signals. This is the write response channel, right? That is the AR channel. That is um, read address channel. Okay. Write response channel. What are the signals we are having? See, I told you that write response channel. After sending the master address and data, okay, we need slave must be need to reply for that. Okay, that will be happen here. So write response channel is the final status of your transaction. That status you need to send to the master. Okay, slave will send the status of the data or address. Okay, is that received properly? Then B channel carries that write response. Okay, so from slave to master. Okay, that is the targeted slave, and then who is initiator? Master is always initiator. Okay, so then it will send the response to that initiator. Slave will send that response to this initiator through B response channel. Okay, and B user also there, and then B valid and ready signal. So valid and ready signal should be high, then only sampling is happening. So this is the signals BID, response, user, valid and ready. Valid and ready are 1 bit signals. ID is depends upon the bit, and also response signal is a 2 bit. Okay, so it 2 bit width, the width is 2 bit. So based on that, it will send that OK response, exclusive OK response, or it will be sending normal response. Okay, local response. It will send that. See, this is the response channels. It is a 2 bit width. So, OK response. OK response means normal access. That means master is sending the data, slave is responding. There is no problem in that. And then XOK response. If you are doing some locked access, all these things, then exclusive OK response will be transferred. And then slave error. Slave error means the slave is not responding. Okay, slave is not responding, that means internal error you are happening, then slave error will be getting. And then decode error, whatever the address you are transferring, that address is not there, that means not matches to your slave. Okay, whatever the transaction I'm sending, so address is placing first, right? That address, whatever the slave we are having, in that slave that address is not matching, then slave is not matching. At that time, decode error will be happening. Okay, and then timing and sequence. So how we are sending the master, the address base AW address is sending by the master, and then data beats is also sending by the master, and then slave is responding through value. Slave is responding through ready signal. So if it is slave is ready to receive the data, and then B channel will give you that response signal. Okay, either OK response, exclusive OK response, or slave error, all these things. After all the data you are transferred, see, data 1 and data 2, so this is data 1, data 2, data 3, data 4. That means your AW length is 3 bit, then burst length is 4, then 4 bits of data you are transferring. Okay, after that fourth bit you need to place the OK signal should be high. Okay, after all the signals you have transferred, then OK signal should be high. Okay, then after all the data are transferred, then last signal should be high. Okay, your last signal should be maintained high after sending all the data. Okay, and then valid and ready signal should be high, then only the OK response will be sending. Okay, here it is somewhat this is the valid signal and this is the ready signal. Okay, then OK response will be sending. For all bits of data transferred, that means one transaction is happened, then only the OK response will be coming, not for individual data. While reading the data, you will send OK response to individual data. Individual byte, you can send the OK response. Okay, here after transaction of all the data, then only we will send the OK response. Okay, so the B channel will gives you that final confirmation to that writing is happening properly, and then response is written through your slave based on the transaction. So what type of transaction you've done, that will gives you the response, and written back to the response is written back to the master. And then response is also independent and it can also delay. Okay, based on the slave is ready. Based on that, you can send the response. See, B valid is missing. So if you are waiting for B valid, so you are missing the response because master want to set the valid signal should be high. Then only slave, whenever the slave is ready to receive the data, whenever you are maintaining valid data, then slave is ready to receive the data, it will send the ready signal should be high. That's it. That is the common mistake. Don't wait for slave should be ready. After that only I will set that valid signal should be high. Don't do that. So valid signal should be maintained high throughout the entire transaction. And then response we are getting the error. That means we may get some blocked access or slave is not ready or misalignment. So address is mismatching. Address is not found in any slave. At that time you will get the error response. Okay, BID is mismatched with AWID. That means WID is same thing and B response ID is also same. So suppose your ID is one and then response is coming to the second ID, that will be causing mismatch to your data. Okay. So assuming that response comes per bit data is equal correct. Okay. All bits of data transferred, then only we will get the response. Okay, so final conclusion of B channel is this is the final status of your write transaction. So write whatever the B channel is there, that response it gives you that final response to your write transaction. And then read address channel. Hmm. Fine. AXI read address channel. This read address channel is sent by the master. Based on that address channel which data you want to, so this is the control information channel. Okay, so it will send that address as well as control information. So that means based on the address you send, and then you can send the control information you want to get 32-bit data or 64-bit data or some 128-bit data. Based on that control information we will tell you that which type of data you are transferring. And also we have different byte lanes of data. So here master is initiating the transaction here. Okay, according to that slave will be respond based on that id, address, length, size, burst, locked, and then protect, signal, catchy, region of quality of service, region, which region you want to operate it, and user want to do some other data, then handshake signals. All these signals are also available in your write address channel. This is common for every slide. So master will send by the valid signal and then slave will be sent by the slave ready signal. Based on that, we will know that transaction is happening or not. So this is the signal. See, if this is the passage of the clock. At this condition, valid signal will be high and ready signal should be high. Then only data transfer is happening. Based on that, address signal, ID signal, length, and all these signals. Okay. So AW valid is high and ready signal is high at the rising edge of the A clock, then only we will sample the data. After that, later so we will return the data based on the R channel. Okay, so R channel gives the data. First, we need to place the address from which location you want to get the data. These are the signals. See, length is 8 bit. So if it is AXI4, length is 8 bit, and then size is 3 bit, and then burst is 2 bit, locked is 2 bit, protect is 3 bit, and then catchy is 4 bit, quality of service is 4 bit. Okay, region is 4 bit. Okay, user is depends upon the user bit. How much bit you want to give the data. And valid and ready signals are what it called 1 bit. All the signals are master to slave only sending, valid only, ready only sending from slave to master. Okay. And then length, burst length, that is tells you that number of bits you can transfer. So 4 bits of data you are transferred if you are taking 3 bit. Okay, its length is 3 bit. And then catch signal, I told you that bufferable, catchable, readable, and then writable. Okay, so and then ordering signals, AR lock. So if you are doing that exclusive access. Okay, exclusive access, I told you that. So this is the master. Okay, and this is the slave. In my master, this master want to communicate with this slave. Okay, so it is accessing some at particular memory location. That means some 0x a location, it is accessing the data. Okay, another master want to communicate with this master 2 want to communicate with this the same slave. If it is having the exclusive locked access, okay, so in this some particular memory location you want to access that, it will be allowed that whatever the address is accessed by the master 1, if you want to access same location, it will not allow that. This entire slave is free except whatever the master one is accessing some particular address location, that location is not gives the access. Suppose if you are doing that locked access means entire slave is locked. Okay, master one and then slave one. Master is communicating with this slave and then it is locked. Okay, it is locked access. We are doing that, and then master two is want to communicate with the same slave. This will not allow the transaction. That is called other signals like AR lock and then quality of service, all these things. Okay, see, address is 0x 1000 and then length is 3 bit, burst length is 4 bytes, 4 bits, and then size is 2 bit, and then burst size is 4 bytes of data, and you are transferring increment data transfer. Then you can calculate that. Start address is 1000, increment by 4, 8. So every time it is increment by 4. They depends upon the number of bytes of transfer. This is 4, right? So then 1004 is the next address. This system will be calculating automatically. It is also adding another address 8, and then so C, and then 108, then 200. Okay, 2000. Based on that, it will increment the address. Okay, and read data channel. So after placing the address, then slave will gives you the data. So based on it will returns that master is requesting, slave is responding. Okay, always master is requesting the data. So then slave will need to respond to that and then give the data to the also response as well as data also it is giving that same signal. See, RID will tells you that what type of ordering we are doing. It will track the ordering rules. R data, R response, R last, and R ready. All the signals are same. Okay, same signals we are using, and then burst size, all these things. See, this is the waveform. Look at here. How we are doing. Every passage of the clock. Okay, data is there, valid is there. Whenever ready signal is high, valid signal high, then only we will send the data. So each data we are transferring, then we can send the OK response. Because each and every data is received by the master or not, then only we will send the response signal. This response will send the master to slave. Okay, so master is sending this our response signal. Okay, see, response signal, that is slave to master, we will send that. Sorry, slave is sending the response signal. Okay, but there is no response channel is there. Okay, during the read channel only we will send the response signal. Okay, along with the read data we will send the response data. Then only each and every data we will send the OK response. Okay, so at that time we need to maintain valid signal should be high and ready signal should be high, then only we will accepting the data. Okay, see, burst example, how we are example, the AR length is 3, 4 bits of data transfer, and then size is 2, then 4 bytes of data transfer per beat. Okay, so this is data 0, data 1, data 2. So increment burst he is taking that 0, 1, 8, 1, 0, 0, 4, 0, 8, and then 1, 6. Whenever that last data is happening, then only our last signal should be high. But response signal should be each and every data you are transferring, you need to send the OK response. Okay, R last is accepted high when all the data are transferred. Here, 4 beats of data you are transferring. Then fourth beat you need to set the R last signal should be high. Okay, so that is the last signal. And then I told you that OK response, exclusive OK, slave error, and decode error. Decode error means address is not matching with your particular slave. That means your slave is the slave cannot have that address. Then mismatch is happening. Then only we will get the decode error. Slave error means the slave is not responding, not initiating any transaction. So that means slave is mismatch is happening or the slave is not responding. Then we will get the slave error. Okay. This is complete AXI channels, write address channel, read address channel, write data channel, read data channel, write response channel, all these signals. So AXI write transactions. How we are doing the write transaction? I told you that, right? First, we are placing the address. Okay, see, look at here. Address we are placing there in the address space. At that time, valid signal should be high and ready signal should be high. At that time, we need to maintain address should be stable. Okay, and also right after placing the address, we will place the data. Okay, data and then valid signal should be high, ready signal should be high. Whenever we place the data, we need to get the response. Okay, this is single data, then OK is high here. If you want to transfer multiple data, same address we need to place at the passage of the clock, and then valid signal should be high and then ready signal should be high. After that, I am placing data 0, data 1, data 2, and so on. So data n minus 1. Based on that burst size, we will place the number of data and burst length. Based on that burst length and burst size, we will place the number of data. Okay, multiple data we are placing there. Entire transaction, see, valid is high, here also high, here also high, here also high, here also high. Entire transactions ready signal should be high. Then last signal will be placed after transferring the last signal, then w last will be high here. The, here right response, single OK response we will send, not sending for each data OK here, and this is data to OK response, this is data OK response. This will be happened in read address channel, sorry, read data channel. Okay, in read data channel it will be happened each data you are transferred from master slave to master, then you can send the OK response. Here write transaction, all the data are transferred, then only the OK response will be placing. Okay, this is the write transaction rule. See, same thing will be happen. AW address. Okay, after that accepting the address, then write is happening from master to slave, and then last bit of data transfer, then W last will be 1. Okay, then write response will be sending from slave to master. So this is the important point. W, AW and W channels is independent of address. Whatever the address you are sending, and then address phase, and then address can be accepted before that data phase. So you need to place the address first. After that only data is placing. And then W channel can transfer multiple bits of data, depends upon your AW length and AW size. And then last signal will indicates that your burst transaction is completed, and B channel gives the status of your write transaction. Okay, what type of response you are getting, OK or exclusive OK, slave error or decode error, it will get that. So this is valid and handshaking rule. Valid signal and ready signal should be high. Based on that we will maintain transfer signal should be high. These are the common signals. Okay, similarly read transaction. how it will be happening. Same thing we need to play. See, there is no response channel here, only address phase and data phase only there. Okay, I need to maintain. See, during idle condition the address is not maintained, and then valid signal should be low, ready signal should be low. Whenever you are maintaining the address, the valid signal should be maintained high, and also ready signal should be maintained high. After sending the data, read data we are sending, that means slave to master we are sending the data. Then valid signal should be high, ready signal should be high, last signal should be high, and response okay should be high. Valid, ready, response okay. Sorry, valid, ready, and then last signal okay signal, response signal. If you want to send multiple data, okay, address, valid, ready, all are high during the data transmission address phase. In the data phase, data 0, data 1, data 2, data 3, and so on. So n plus 1, n minus 1 data so you are transmitting. Each data we need to maintain valid, ready, and then okay response. Why we are not maintaining last signal here? Because this last signal indicates that your last data transfer. Here remaining data are also there. Then OK response is placed here, and OK response is placed here, OK response is placed here. After reaching the last data, we need to place the our last signal should be high. Okay. Same thing. Master drives the address signal and then valid signal. Ready signal should be sent by the slave. Then only we will accept the data. Okay. After accepting the data, slave will return the R data. After that, slave is ready signal. Valid signal should be maintained by high by the master, and slave ready signal should be sent by the slave. So then the data is happening. R last is accepted whenever your last data is transferred. Then R last will be accepted. Response signal, you're sending the OK response, exclusive OK response, slave error, and decoder. Okay. Any doubt? So all the write transactions and read transactions happening properly depends upon the valid signal and ready signals. Okay. So data interleaving. What is interleaving? Interleaving means, so one transaction is not completing, the next transaction is placing in that. See, this is the read data interleaving. AR1 is the first address channel, and AR2 is the second address channel. In that, we will get the data. So through R channel, I am getting R11. If R1 is R11, that means AR1 is not completing, AR2 is placing that. Okay, that means you are doing two or more transactions. So then, instead of waiting for the other transaction to complete, the next transaction will be initiated. Why we are taking the interleaving means, I don't want to stay, my bus should be in idle condition. That's why interleaving is happening here. So suppose you are transferring one data, suppose four data you are having. Okay, so two addresses I'm having, address 1 and address 2. In this, data 1 is happening, and then without completing the data 1, data 2 is also transferring here, and then address 2, data 3 is transferring, and data 4 is also transferring. Okay, so that is called interleaving. See, I will tell you here. So there are two or more transaction data transfer. Instead of waiting for one transfer to complete, before that other starts. One transfer is not completing, I am not completing talking with you, instead of that someone is talking. Okay, so that is the interleaving. That means after completion of my data, after completion of my talk, you can respond, or in between that other person is entering. That is the, see, here I am having two read transactions, data 1, id 1 and id 2. So interleaved on R channel. That means data bits from both IDs are written alternatively. So it improves that utilization of your throughput. That means your idle. So suppose I am staying idle here. Okay, at that time I want to read something. Before coming to the class I want to read something, and after you are coming, then I will start my class. Then I am engaging myself. So that is the interleaving here. See, read interleaving and write interleaving. So write interleaving your w id1 and aw2. So based on that address channel id1 and id2, and I am sending the data w11, that is the first address channel id1 data. Similarly id1 having three datas. So first data is completed, second data is not completing, and then id2 is happening. Okay, that means I'm equally maintaining so parallelly maintaining that. So I'm balancing both the persons. Suppose two persons are there, I don't want to wait until you need to complete a first person complete all the data. So in between that I'm also assigning some work to you, because you are staying in idle condition. I don't want to stay idle for you. Okay, so three transactions are there. First transaction, first one is happening. Okay, so then come to the next person, because suppose the first transaction is having 10 transactions. I don't want to wait that complete 10 transactions is completing for the first transaction. For complete 10 transfers are completing, then only the second transfer is happened, means that person is waiting or not, I don't know. He may be late, right? If you went to some other shop, so then you are buying something, someone is saying one thing, and then he is thinking in that. Then shopkeeper is asking you, okay, what do you want? He's thinking, right? So he's not completing the data. So he is not completing his purchase, and then he is asking the second person, because he don't want to wait idle, and also second person is waiting, second customer is waiting. So then he is asking what you want. Then whatever you want, he will give you that data. So that is the interleaving. Out of order transaction. See here, fast slave is there, slow slave is there. Same master wants to communicate with the faster slave and slower slave. Who is responding, who is giving the response first? Faster slave only giving the response first, right? So then out of order transaction is happening when depends upon the multiple masters are there, multiple slaves are there, which master is communicating with which type of slave. If it is communicating with the slower slave, and response is coming late. If it is communicating with the faster slave, the response is coming fast. See, out of order transaction, how we are saying here. So in this clock I am placing the AR channel here. Okay, after that id1, then slave is giving the response. This is the slower slave, this is the faster slave, and this is the fastest slave. Okay, two fastest slaves are there, one slower slave is there. Then id2 is first responding, id3 is next responding, id1 is responding last. That is the out of order. That means id2 id3 are completing before that id1. Okay, because id1 is the slower slave, id2 and id3 both are completing faster, because it is faster slave. Understood? If it is having same id, then completing one by one. id1 r11, id1 r12, id3 r13, same order is coming, right? But here R21, R22. But in between that R31 is coming. R2 is completed, R31 is coming. But actually this is in same order. But your order ID1 is coming last. But ID3 is coming first. So this means R31, R32, R33 is coming first. And then next R21, R22, R23 is coming next. After that, first response R11, R12, R13 is responding. Then fully alternative. Fully we are getting outstanding out of order transactions. Okay. So these are the outstanding transactions, out of order transactions, and interleaving. Understood? Right channel ordering rules. How we are sending the right channel ordering rules. See, interleaving only. So based on that interleaving, so AW1 is the right address channel, AW2 is the right address channel 2, ID1 and ID2. Based on that, see, interleaving is happening, right interleaving is happening. Okay, so what it happening, W11 ID11. So after that, before completing the ID1, ID2 is entering in between the ID1. Okay, that is the right interleaving. That means right channel ordering rules. And then right ordering rules depends upon the interleaving is allowed. And then order should be maintained same order. If you are maintaining ID should be same. Okay, within the id same id, then you will get the same order signals. So no out of order in right channel. Why we are not having out of order? Because we are placing the data into the slave. Then why we are placing the data in the out of order? Okay, so right transaction, see, AXI does not suppose that out of order beats on the right channel, because slave must accept the data in the same order, but slave can give the response in any order. I am transferring the data to your in the same order. I don't want to show any partiality in between you. Okay, so then your response may come in any order, right? So that is the out of order transaction. So right transaction rule, right ordering rules does not support out of order transactions. Okay. The response may come in any order. See, and transfer interleaving may be happen. Interleaving may be happen means right data is happening after completion of right first data, second data is transferred, and then before completion of the second data, then first data is involved. So based on that, data are we are keeping in the channel, data channel, and the response may coming in any order. B response is coming first, and then B1 response is coming next. Okay. Similarly, same thing will be happening. See, what are the features? Quick reference. Interleaving is allowed in AX right address channel, and then B channel is response is not available here because interleaving is there, and then out of order is not allowed, and then B channel is allowed. Response may come in any order, and then out of order within the same ID. That means we need to maintain same ID, then only we will get the same order maintained. Okay, so it must be maintained same id and then same order. So AXI3 and AXI4 is removed here, right? W right interleaving is removed in AXI4, AXI3 is supporting. Okay, read interleaving responses are supported by the AXI3 4 and AXI4 line. Okay. So these are the right channel dependencies. What channel you are depending on? There before that writing the data, you need to place the address, right? After the placing the address, then only writing is happening. So valid and handshaking is happening. Dependencies on valid and ready. Okay, valid signal should be dependent and ready signal should be. Handshaking is in each channel. So dependencies depends in order of relationship between the channels. That means what type of transaction you are doing, that order is doing here. So first we need to do the handshaking. So ha address handshaking. AW valid signal should be high, then only slave signal should be high, and also W handshaking. Valid signal. See, anything is happening means, so first we need to check each and every channel handshaking is done properly or not. Okay, and then B handshake. That means R W last should be high. Once all the data are transferred, then only W last signal should be high. Okay, so B valid is response, and then only after all the signals is getting high. Okay, so only after that address is handshaking is completed. That means AW valid and AW ready is high. Then only B valid is responding, and then all right data bits are accepted. Then only we will done the handshaking signal is completed. So first done, second data, third data, all the data are completed. Then only we will send the response signal. See, this is the example scenarios. AW is accepted first, after that write data, and then W last is accepted whenever the nth data is transferred, and B valid should be high, and then B ready should be high. Then only we will complete the transaction. These are the dependencies, signal dependencies. Okay. See, transaction 1, AW1. Okay. So same thing, AW1, AW2, ID1 and ID2. So ID1 signal, ID2 signal, ID1, ID2, ID1, ID2, response is coming in any order. So based on the interleaving and then out of order transactions. Similarly, read address channel dependency, same thing, interleaving and then read address channel. We need to place the master, we need to place the address. Okay, master initiate the address, then only slave will respond. See, valid and ready signal handshaking is happening. So master is initial, from master we need to maintain the valid signal and ready signal should be maintained high. So address to read it. So AR address channel and then read address channel, read data channel. These two signals are dependencies. Same thing, interleaving is happening. So AR1 and AR2, ID1 and ID2, so responses are coming in any order. So we are having both valid and ready signals only. Sorry, address and data signals only we are having. Okay. So what are the dependencies here? Read transaction we are doing this. Read transaction we are doing read transaction AR to R. After setting the address, then only we will send the, so R is depends upon AR only. Okay. From master to slave and then slave to master is happening with that. Okay. So up to this you can read.